Hello everyone, welcome along again to Space Dave Live, episode number 5. Awesome to have you guys with us here tonight. I think everything's under control for our live show tonight, and the good news is we think we actually have the comments going properly this time so I can actually see them. So I'm really looking forward to being able to interact just a little bit better tonight, so that would be awesome. So as usual tonight we have a studio audience here with us. As usual, it's a very small audience, but thank you guys for coming along and joining in again. Now look, if you want to come along and be part of our studio audience, you're more than welcome to come along. It doesn't cost anything. It's a lot of fun, so we'd love to have you here. Of course, for those of you who don't know, we are in a very small town here. Whoops, I'm just going to turn my audio down here a little bit. We are in a very small little village here, so it's going to be hard pulling people along every single week, but we're going to keep giving it a try because it is a lot of fun having a studio audience here. So you saw Jess in the audience out there in Carston, and then over the back there we have got Floyd keeping an eye on social media and technical stuff over there. So tonight, what have we got for you tonight? Let's have a look at our program, shall we? That would be a good start. So here's the rough plan tonight. We'll start off with our introduction and whatnot. We've got a lot of news. There's just so much news happening in space at the moment. We've really picked a good year to start doing this, I think. There's a lot of news happening, and I think the big news tonight will be to recap the black hole photo. But we also want to definitely talk about the Falcon Heavy launch. That was big news last week, and there's a few other things as well. In the night sky tonight, a couple of things to look at, but we will also be pointing out where the galaxy M87 is, and that's the galaxy that the black hole photo came from. A couple of other things tonight, we'll get there later on. So that is, generally speaking, the outline that we have got for tonight. So as always, we like to start off with competition time. Now, we had a suggestion last week from John. I think it was John, wasn't it, guys? Thank you, John. His suggestion was that we ask you, what is my favourite space mission? So there you go. You want to have a guess and guess what is Space Dave's favourite space mission of all time. Now that could be past, present, or even future. Why not? So have a guess at what the space mission I am most into. What else do we have to talk about? Now I noticed that, well, the thing with the comments, hopefully we're going to do a lot better now, and I'll be able to react to your comments a lot better, because what I've noticed in the past is I go back after the show and read comments and realise that there's a few that I kind of would have liked to have responded to. So my apologies if I haven't responded in past. There's a couple of things I wanted to mention. One of them was someone had asked if I have tried Space Engine. So the short answer is yes, I have tried it. It's not quite suitable for us at this point, but I really am hopeful about it and being able to use that one in the future. So thanks for that suggestion, and we will carry on with Celestia for now, but I'm hoping that we will be able to use Space Engine. Also, Mike from Cambridge, I did get your email. Thank you for that. Didn't really get time to tackle your questions for tonight's show, unfortunately, and I want to do them justice, so I'm just going to have to put them off for now. Sorry about that, but we will get back to them. So let's talk about some news, shall we? So first up, we should talk about what's been happening at the Space Centre here. So it's school holidays, of course, at the moment, so we're very busy. Lots going on in the holidays. So I've actually got a quick clip here. Have a look at what it was like. This was yesterday, so there's a bunch of people coming along. This is sort of what it looks like in the school holidays here. Those guys are having a go on the virtual reality headsets there, which is a lot of fun, earning the astronaut wings and doing a whole bunch of things. So it's often busier than that in the holidays, but usually it's not too bad. This was today, just a couple of hours ago. We had a group of 60s plus from Matamata. Thank you guys for coming along. We had a lot of fun with you guys today. So it's all on for young and old here at the Space Centre in the school holidays. I don't think there was anything else that I really needed to talk about with what's happening at the Space Centre. So that means that we can get straight on and talk about news from space. So where should we start? I think we really probably need to start with the whole black hole thing, really, don't we? That's the big news, obviously. We talked about it a lot last week, and the big question was, what is the black hole photo going to look like? So if you remember, I did my little prediction about what I thought it was going to look like, and I was pretty stoked that I was quite close, I think. So this is what the photo looked like. You will all have seen it all over the media by now. We were certainly right that the mainstream media did pick up on it. So the good news was that I watched the press conference. I told you last week that I was going to probably do an all-nighter, and that is pretty much how it turned out. It was a lot of fun though. So I stayed up. The press conference started about 1 o'clock in the morning. They released the photo, so I was a bit nervous about that to see how close I was to what it would look like, and I was pretty close to it really, I think, so I was stoked with that. To be honest, it wasn't actually that hard to figure out. As you know, I just came up with some simulations that other people had done and just based it on that. So it actually wasn't that hard. So one of the other things that happened with when we were watching the press conference is right from the start, the woman, I believe from the National Science Foundation, who was introducing the whole thing, started talking about photographing the event horizon. So last week we had a question from Caitlin asking, would we be able to photograph the event horizon itself, like actually get an image of the event horizon? And I very confidently said, no, I don't expect that we will be able to do that. And then, so when they started talking about, or implying that they had actually done that, I was confused, rather shocked actually. It was, I wasn't really quite sure how that was going to unfold. Come on guys, yeah, come on in, come and have a seat. Yeah, we've still got people arriving for our audience, so do you guys want to come in and have a seat? Yeah, we're already underway, so yeah, you just come on in and grab a seat, it's fine, just come and sit down. So, sorry, where was I? So we were, yeah, the question of the event horizon. So I was somewhat perplexed when they started saying or implying that they were going to be able to see the actual event horizon. Throughout the press conference, that they talked a lot about the photo, but they didn't really, to my mind, explain clearly exactly everything that we were looking at. And they didn't even really mention the event horizon until after the main conference. In the question and answer time, someone asked more or less, where is the event horizon in this? And one of the scientists said that the picture effectively goes right up to the event horizon, and was very strongly implying, I thought, that this was a photo of the event horizon. And he was saying that there is a sharp cutoff point. Well, to me, when I look at that photo, I don't know about you, but I don't really see a sharp cutoff point. And my best guess was that he was sort of maybe saying that the event horizon was around there somewhere. If you recall last week, I was guessing that the event horizon would be somewhere smaller in there somewhere. So I was very confused by the whole thing. And I spent the rest of the night trying to figure out what was going on. I stayed up till about 5 o'clock in the morning, couldn't really figure it out. So I went to bed thinking, well, I'll leave it to all the experts out there, fully expecting that the next morning I would wake up and there would be all sorts of lovely graphics with this, showing size comparisons with various things and an outline of where the event horizon was. That's what I expected someone to do, so I just thought I'll wait and let them do all the hard work. Well, it sort of didn't really happen actually, and it must have been about 24 hours later. Randall Munro from XKCD, who is well known for getting things right, he came out with this little graphic here that showed our solar system in comparison. So that was the first thing to sort of give an indicative size of what we were looking at. So based on what he had done there, and assuming that he had got his maths right, and as I say, he does get his stuff right pretty much. So I took from that, if we assume that the radius of the black hole, according to Wikipedia and other sources, was 125 astronomical units, and the distance to Voyager 1 that you can see there is 145. An astronomical unit, by the way, is the distance on average from the Sun to the Earth. So Voyager 1 is 145 times the distance from the Sun to the Earth. So bearing in mind all of that, I calculated that it would be roughly that circle there would be the event horizon. So I thought, okay, well that's the closest thing we've got so far, but it didn't really stop there. There seemed to be a fair bit of confusion. Very soon after the announcement, Katie Bowman put out a video for a lecture that she did at Caltech, which included this image here, which kind of to me implies that the event horizon is actually around that main ring that you see there, although she didn't specifically say that. So that was also a little confusing, but there's more twists to this. I sort of carried on waiting and looking around, and I came across a bunch of opinions. Now, I'm not expecting for 1 minute that you're going to read all of this stuff, but if you do want to grab a screenshot of it or come back and pause the video, there is some interesting stuff in there. But the point is that this is showing various interpretations of sort of more or less what we're seeing. First of all, on the top left there, this is actually an old simulated view of Sagittarius A star, the black hole in the middle of our galaxy. So what you're seeing there is the white circle, that is where they think the event horizon is. And that kind of image and that kind of information is really what I was basing my expectation on, that the event horizon is smaller than the dark area or the shadow that you can actually see. Down below it is an article that came out in Forbes by Ethan Siegel, who's an astrophysicist, and he noted that the ring of radio doesn't correspond to the event horizon itself, which seems to be quite clearly saying that that picture that we are looking at there is not where the event horizon is, so that further confuses it. The big thing is that I found was a guy called Matt Strassler, who's a particle physicist. I've been following him for a long time. Very, very clever man. This is not his area of expertise, however, he is an expert in physics and all of this kind of stuff, and he knows all the right people, and he was able to talk to the right people. So I was very interested when he put his first reaction out, in which he made a couple of interesting comments. In the first one in the top middle there, it said, at this point we still haven't figured out what the event horizons experts do and don't know about this question, or whether they agree amongst themselves, and that seems to be an important thing later on. I'll also point out that a lot of people were watching this a video put out by Beresheet, which is a really good video. It's been very popular over the last week, explaining how black holes work and what we can expect to see, but it's really important to note that their video was made before the announcement, and it's talking about a different kind of black hole. So as much as I love Veritasium and their video, it's probably best not to use their one as a guide for what you can see in this photo. Moving on, just today, just a few hours ago actually, Matt updated his blog post or posted a new blog post. So he'd been saying that we're actually really not sure where the event horizon is or what's going on. So he has managed to talk in the last week to people such as the Event Horizon Telescope, so who leads the Event Horizon Telescope Science Council. So this is pretty much as high up the chain as it gets, and the takeaway from that is, as you can see here, it's not at all clear what the EHT image really shows, and that is from the people in charge of the entire project. So I kind of felt a little bit better about that, and that together with some of the other diagrams that you can see down here actually kind of goes back more towards what I had predicted. Although I really need to be clear about this, my explanation was perhaps a little on the shonky side, or at least incomplete, because I hadn't taken into account the bending light rays, which I really should have done. So when I look back at it, I thought, oh yeah, that was pretty obvious, wasn't it? However, what I had showed you last week turns out to be kind of about the best guess. And you'll even see down here, it says the dark patch is 2 to 5 times larger than the event horizon of the black hole. So this is from the authorities themselves, apparently quite clearly saying that the dark patch is bigger than the event horizon by quite a long way. So if we go back here, the event horizon, according to them, should be, sorry, excuse my scribbling, it's shocking, isn't it? In there somewhere, which is more or less what we said last week. So at this stage, as far as I can tell, the event horizon, the physical outline of it would be in there somewhere. But of course, it's even more complicated than that. Because of that thing of the bending light rays. Now I've got a quick video here. We don't actually want to see the whole thing. I'll bring that up, and I'll probably just have to zap forward a little bit. This is a simulation. Let's just, oops, I'm doing the wrong thing here. Let's go over here. So this is showing you, let's just pause that there. These are all photons around a black hole in the middle. So these are rays of light that are traveling around, and it shows you how they get bent as they go around the black hole. So you can see light rays or photons coming from various directions are all going to get twisted around and out in that direction. And if we come around this way, I'll just pause it there. At this point, you can sort of see that the event horizon is back there in the background, but the shadow, the dark part, is actually much bigger out here. So I think that's, from what I can gather, that's kind of what we're looking at. We're looking at the shadow, the dark part, or the silhouette, whatever you want to call it, being much bigger than the event horizon. So that is a very long-winded way of saying we actually don't know where the event horizon is. The physicists themselves seem to be a little bit unclear exactly where the event horizon is. It could be that, in fact, I think it's most likely that we are actually looking at a bit of a mirage. So we are seeing light coming sort of from the event horizon, but because of those bending light rays, it's distorted the whole thing, and we're not exactly sure what it is that we are looking at. So I'm hopeful that we will figure that out in the weeks and perhaps even months to come. It could take quite a while. So that was the big thing about the event horizon. I really did want to just clear that up. Let's see, there was another couple of things that I quickly wanted to go over with the black hole. So one of the things about the black hole is the question about whether or not it is a rotating black hole. Which, sorry guys, I didn't mean to cut to your camera there. We've got some new people in the audience. Wave out everyone. Hi guys, nice to have you along tonight. Thank you very much for coming along. What I actually wanted to do, what I meant to do was cut to this picture. Sorry about that. Is this a rotating black hole or not? For most of us, it's not really going to matter that much, but it is quite important when we're talking about what we're looking at. And a lot of these tests, you would have heard of a lot of tests that we're testing Einstein's theories and things. It actually does make a difference whether we are talking about a rotating black hole or not. And here in New Zealand, we are especially interested in that because this gentleman by the name of Professor Roy Kerr, who lives in Tauranga, and he is a guy who did a lot of very important work. He actually figured out a specific solution to one of Einstein's calculations that is related to rotating black holes. So if we assume that we are looking at a rotating black hole, Roy Kerr's his work has been shown to be correct, which is a big deal. That's really good news for New Zealand and especially for Roy, of course. Now, the scientists from the EHT have been saying that the image proves that this is a rotating black hole, often called a Kerr black hole, as opposed to one that doesn't rotate. Now, a bunch of other physicists have come out and specifically said this is not a rotating black hole or it is not a Kerr black hole. I'm not going to comment on that. I don't really know. I'm just going to have to wait like the rest of us, like the rest of you guys, and see what the outcome is there. But I kind of hope it is. I hope it turns out to have proven Roy Kerr to be right. So we'll just have to wait and see what happens there. A couple of other quick things to wrap up the black hole thing. You may remember the LIGO project. This is the thing that detects gravitational waves in space, and in particular it detects merging black holes which make strong gravitational waves. This has been offline for an upgrade for a long time and has actually just coincidentally come back online with its new upgrade, and apparently it is already detecting new gravitational waves, so it's much more sensitive now than what it was, and they are expecting to come up with new detections of black holes merging and other things merging in big events in space pretty much every week. So it's really interesting. We'll definitely be keeping an eye on that. One other thing. You may have come across in the past, I think we've talked a little bit about it, citizen science projects where you can do science projects at home. You can be involved in what scientists are doing. You can download data from the net and you can run things on your computer to help out with those projects. You can either have it just automated, so it's just using your computer, or you can actually do things and to get involved in it. So a new one that has just come out, again coincidentally, it's called Black Holes at Home. If you are interested in that, just Google Black Holes at Home, and this is a way to be involved in finding new black holes, gravitational waves and other bits and pieces. I haven't really looked a lot into this myself, but it does seem to be interesting. Unfortunately, like a lot of these citizen science projects, the explanation and the wording to help you get involved is not intuitive. These guys are brilliant, but often not that good at communicating what they're doing, so it's a little bit dense wading through a lot of this. But anyway, if you're interested in that, hopefully you'll have some fun there. How's our time going? Hang on, I've got another note here. Righto, thank you. Righto, so we'll just keep an eye on the chat here. I think, was there anything else, Floyd, that we need to look at? Okay, thank you for that. Now, I was going to fit in a quick rant here, and I think we can, so let's get ready for this. I'll just have a drink, because I need a drink before I start ranting. This is still related to the black hole, which is why we're putting it in now. So I wasn't going to touch this one for reasons that may become obvious, but a few people have asked me to comment on this. So here we go. Now, if you remember last week, before the announcement about the black hole, I recommended this video by Dr. Katie Bowman, in which she very eloquently explained how the whole imaging process is working for this project. And I said, go and check out her video because I think she's one of the best communicators on the whole team. So she is one of the scientists that was working on the team for this project. She's one of about 200 scientists that have been working on it. The next morning, nice and early, I saw this lovely photo on MIT's Twitter feed. I think that's a lovely photo of her seeing the first image on her laptop there. And I thought, oh, that's a cool photo. That's a very shareable photo. We'll probably be seeing that in the media. That's pretty neat. That really captures a moment. And not long after that, this showed up on CNN with the same photo and the headline, "Thank this grad student for making it possible." Okay, fair enough. And what does it say here? The effort wouldn't have been possible without Katie Bowman, who developed a crucial algorithm, etc. So, yeah, fine, but I mean, yes, we're starting to get a little bit into the exaggerating area there. I mean, yeah, to say it wouldn't have been possible without Katie is a bit of a stretch. It's kind of like saying my car won't work without the back right wheel. Yeah, that's technically true, but I could just put another wheel on, and honestly, no one is indispensable in a team like this. She did really important work. I've got a lot of admiration for the work she's done, and she's a very good communicator. It's just a bit of an exaggeration to say that it wouldn't have been possible without her, but that's what you get with the media. You know, a photogenic person, a bubbly personality full of lots of infectious enthusiasm. You know, it's a good story, so yeah, we're happy with that. Then we get this. I see this come up on, I can't remember what site it was, it might have just been Facebook or somewhere. Today, everyone is sharing the first ever image of a black hole, but no one is sharing stuff about Katie Bowman, the young lady who is single-handedly responsible for it all. Okay, well, gee, that's a bold claim. And to her credit, Katie very quickly came out and said that's absolute nonsense. There are 200 people who were involved in this, and she was one cog in a large wheel. Yeah, this is starting to get a little bit annoying here because it's really distorting it quite badly. It's very insulting to all the other people who work towards this. And not to mention where it says everyone is sharing the image but no one is sharing stuff about Katie Bowman, because at the time I saw this, she was literally the only face from the entire team that I'd seen on any mainstream media anywhere, or any of the other sites, Reddit and all the others. She's the only one that was showing up, and this came out and I thought, oh, I can see where this is going, and you can see how the other side is going to react to this, and certainly that's exactly what happened. So we had this one on the left here. This is Andrew Chale. He wrote blah blah. You can see what it says there. So basically trying to take all the credit away from Katie and give it all to this guy, which is in a way even more ignorant and stupid than the last one. So then we start getting into this whole everyone piling on, and it just becomes this whole toxic mess of misinformation and finger pointing, and it's just horrible. I mean, look at this thing on the right. It only went viral because the news is desperate to pat a woman on the head for doing anything but making a baby. Oh my goodness. I would call this guy a clown, but there's nothing funny about that. There's a lot of this stuff, and it really started to take over a lot of the discussion, and it was very, very annoying. So, look, I mean, here's a story from the New Zealand Herald, online trolls and everything. Look, it's just so frustrating when you see this kind of stuff. Here's a really cool story, and you get all of these twits coming in here with it, just making stuff up, just inventing things, and that then becomes a story. Here's the New Zealand Herald. Instead of actually talking about the story, they're going on about this nonsense. So it really bugs the hell out of me when this sort of thing happens. If you ever see that kind of thing, look, please just don't go there. Don't get involved. In fact, I don't like giving these people oxygen, to be honest. I don't really like covering it on our show here because I think it's best to ignore it. But anyway, I guess I probably don't really want to go on about that because, look, I'm eating up our time. But just that's the basic gist of it. There's a lot of misinformation about this sort of thing. And when you're trying to come in there and say, no, it's not, they shouldn't be having the credit, this person over here should be, pretty much none of these people really know what they are talking about, and the whole thing is just very annoying indeed. So there you go. I think that will be enough of that rant actually, because I want to get on and talk about some of the other stuff. Let's just check a few things here. So let's just double check our chat here. So hi for the couple of you, or one of you who has joined in. Hi Alan, sorry you couldn't make it tonight, but yet we understand that. So all good, we'll see you another time. Right, let's talk about some other stuff, shall we? Because I think there's some much better news, or so much other news to be talking about. I think one of the big things we definitely need to be talking about this, and that is the Falcon Heavy launch that happened last week. So you remember it was due to go the day after the last show, but it was delayed for one day. And it went on, must have been last Friday, wasn't it? So this is the big, powerful new SpaceX launch vehicle. Let's just get straight into it, and we will watch the launch first of all. I think we've got some noise here with it.
7, 6, 5, 4, 3, 2, 1.
Oh, look at it go.
Ignition, liftoff.
So if you remember, this is the second launch of the Falcon Heavy. This is the first commercial launch of it. So it's really, really important that they get this one right. Look at that thing going. 27 engines. It's just a thing of beauty as it goes up into the sky. Love this one to bits. So what's going to happen, there's a whole bunch of things here.
Deep throttle.
Those, the next thing that's going to happen...
33 seconds into flight. Under the power of 5.1 million pounds of thrust, Falcon Heavy is headed to space.
So the next
We're
thing,
throttling down.
okay.
At
The next thing that's going to happen is max Q, or maximum aerodynamic pressure. That's when the rocket is going to experience the most pressure from the atmosphere. It's going fastest, and the atmosphere is thickest, or the combination of those two. So I think we just about must be at max Q now. So this is a part.
Supersonic.
So it's supersonic
You
now.
may have heard the call out on
Booster
Net One.
stepping up.
Vehicle is supersonic. Side boosters are throttling back up on power as we're
Max
through the
Q.
period
We're
of
through it.
maximum
Okay,
dynamic pressure.
we missed it. Right, we just got through it there. So that was maximum aerodynamic pressure. So if anything's going to go badly wrong, that's one of the times where it is likely to happen.
Trajectory looking good.
Next
You
thing.
can hear the applause behind me as we've gotten past maximum dynamic pressure.
Right, next thing is going to be the booster separation.
Performance
So
looks good.
let's have a listen here.
We've
Okay.
begun dropping power on the side boosters.
Right, so what we're seeing here, the top picture is from the ground looking up at the rocket. The middle one is the center stage there. The ones on either side are the two side boosters. So the next thing to happen is MECO, or main engine cutoff, and those boosters separating away and falling back down.
Booster separation confirmed.
All the people in the background there are people who work at
Successful
SpaceX.
separation, if you can hear me over the cheering.
So you can imagine why they're so happy about all of this working.
Side boosters now beginning a flip to begin returning back to Cape
So,
Canaveral.
on each side there, those are the two of the boosters heading back down towards Earth to try and land. The one in the middle is still on the main core in the middle, and so that one's still heading up. And of course the shot from the ground above. So a couple of different views here. We're waiting
Engine
for...
cut off, center core shut down.
Right, so this is the center core separating away. So on the top view there now, you can see the center core just dropped away. So the top one is now the spacecraft that is continuing on into space. The one directly below it in the middle is the center core now coming back down to Earth as well, and the two side boosters on either side. So the three at the bottom are coming back down to land back on Earth.
Looking good, still burning on their way back to Cape Canaveral. Grid fins are out on the center core.
Fairing separation confirmed.
Here comes the fairing separation, and there it goes. We also have successful shutdown of the side booster boost back burn.
So everything's looking good.
T plus 4 minutes, 25 seconds into flight. Side boosters on their way back to Cape Canaveral. Center core coasting out over the
trajectory
Atlantic.
nominal.
Stage 2 looking good with a nominal trajectory.
We love that word nominal. Every time you hear nominal, that means everything's going okay. That's
In
great.
just a few minutes, the side boosters will execute an entry burn, followed by a landing burn, and the center core will do much the same a few minutes later.
So the
Both
two
burns
side ones are attempting to land back at Cape Canaveral next to each other. The one in the middle is attempting to land on a drone ship in the ocean. For various reasons, that one couldn't get all the way back to the Cape. First of all, we're hoping to see the side boosters landing back down at the Cape.
Autonomous drone ship, of course, I still love you. If we have a successful landing today, the side boosters will be reflown on our next Falcon Heavy mission, STP-2.
Side booster entry burn has started.
And there's the re-entry burn beginning.
Okay, so that's just an engine burn to get them to fall back down to where they need to be. The next one will be a landing burn from them, and that's just right before the actual landing.
Side boosters are transonic.
And
Transonic?
there you can see the re-entry burn for center core has begun.
Okay, so transonic means they're back around the speed
Coming
of
up in about
sound,
5
and you've got
seconds
the
here, the side
center core in the middle
boosters
doing
landing
its
burn
burn,
will
and
begin
here we
as well.
go.
Side booster landing burn.
Check this out. Here they come.
You can see the side boosters coming down. And amazing.
Huzzah! Isn't that beautiful? Oh, you're gonna love this. Oh, I love big rockets.
Crazy right now.
It's awesome.
Both side boosters has
What a
landed
beautiful sight that
on
is.
our landing pads.
So the two side boosters have landed perfectly. Well, one of them's actually just a little bit leaning over. You see that one in the background. But basically they have landed perfectly. So now the next thing is for the center core to come back and land out on the drone ship. Now what often happens here is that we lose the feed right as it lands. So that did happen. So then what often happens is we've just got to wait till it comes back, and is it there or not? So, there it is. Yoo-hoo! So
Crowd going wild.
the crowd went wild. Awesome. So this is the first time that they've done this, the first time that they've managed to land all three boosters. So that is really something. Now the last thing is we're back in space, the actual deployment of the spacecraft itself. And there it goes.
Spacecraft separation confirmed.
So of course that's the point of the whole mission, is this bit here. This is the bit that we should be most excited about. But to be honest, that part we expect to go well. If they've
As
managed
you
to
can
get this
tell
far,
behind me,
that should work.
The folks who watched the mission cheering. Arabsat
So there you go, so the
6A
satellite is on its way.
into the
It's been put in the correct order, which is fantastic news. Now, there is one little thing. If we just go back, whoopsie, I think I've lost it. If we go back to, whoops, what have I done with it? Oh, look, never mind. The center core that came back down and landed on the drone ship, absolutely spectacular. Unfortunately, on the way back to shore, it fell off and fell into the ocean. So that was a bit of a downer. So they managed to do all the hard stuff, but on the way back it fell off. Now they are still hoping that they will actually be able to, well, they have recovered it because it was floating, so they're hoping that they will actually be able to refurbish it. There are reasons. There was very choppy seas, and look, I won't go into all the details, but there's a good excuse for it falling off, let's just say that. So that was really awesome. Well done, SpaceX. That's just fantastic news, the way all of that has come together. A couple of other quick photos from this. Look at this beautiful photo. This was on SpaceX's Flickr page. A photo of all the engines just after launch there. I just love that photo to bits. And one other photo that I want to show you from Ben Cooper. This is a long exposure photograph. I've never seen anything quite like that, but I thought that was just a really, really cool photo. So there you go, that is the Falcon Heavy launch. So as you know, if you've been listening to the show before, that's SpaceX's current biggest rocket that they've got, and it's really important that they are getting this big heavy lift rocket up into space because that's one that we will hopefully be using for a lot more deep space missions later on. The rockets that SpaceX has had previously and up until now, and will keep using, are just for low Earth orbit. The Falcon Heavy can get much bigger payloads into low Earth orbit, or it can get things further away into space. So if we're going to go back to the moon and things like that, Falcon Heavy is one of the options. So we're really excited about that one. So here we go. How's everyone going out there in the audience there? You guys all good? Anyone got any questions or comments about anything so far? No, we're all happy. I don't think there's anything we need to look at on. Well, hang on, sorry. I just do want to say, oh, hey, Caitlin. Did you, I'm not sure if you caught the first part of the show there, but we were going over that thing about the event horizon that you asked about last week. So again, thank you for that question. It was really cool, and we talked about it a little bit before. Jenny, thank you for that. Your guess is my favourite mission was STS-31. That's a good guess, that one. I like that one. Righto, so a couple of other things. Yeah, thanks guys. Thanks for all of that. Yep, awesome. Love it. So what should we talk about now? Let's talk about this one. I've got another video to show you here. Let's just, I think I've still, yep, got our audio here. Let's have a quick look at this video. Oh, and I better play it, eh? I better press play. This is a new launch vehicle. Look at that. World's biggest plane. What a monster! It was my birthday. Launched on my birthday. So the idea, this is just a test flight, of course. The idea with this kind of launch vehicle, oh my goodness, look at that. Oh, it's just, wow, amazing. It's a whole different way of launching things into space. So every kind of launch vehicle has its pros and cons, and you want different vehicles for different types of things. So this plane, the idea is that it takes the payload way, way high up into space, and then it drops it out the bottom, and then it gets boosted from there up into space. It's not the first one to do this. So yeah, you would have seen others probably in the past doing similar sorts of things. I'm just trying to think of the mothership, the Virgin Galactic, Burt Rutan's thing, the same sort of system. So they have some pros and cons over normal rocket launches. I've made some notes here somewhere about some of the advantages that I have because I knew I would forget. So they can take off from any runway that's long enough to do it, so you don't have to have a dedicated launch facility like you do with a rocket. Just all you need is a runway that's long enough. It can take off and land anywhere, so that's quite a big thing. It can fly around bad weather, so you often see launches being delayed because of bad weather. It's a really common thing. Something like this, it's not so much of a big deal if you can just fly around it. It can launch a satellite into any kind of orbit. So what we find is that from a certain launch pad, a launch complex somewhere in the world, it tends to be able to launch into certain kinds of orbits. So if you're sort of at the Cape, for example, you're more likely to launch in a sort of more of an equatorial orbit around the Earth. Down here in New Zealand, what Rocket Lab's doing, they can launch things more in a polar orbit that goes the other way. But with a plane like this, you can go in any direction. It doesn't matter. So there's a lot of advantages to having a launch vehicle like this, and we're really looking forward to seeing where that goes in the future. So it's an amazing vehicle. All the best with that one. What else have we got? We need to get through a few other stories here, don't we? We're not going to get through all our news stories, so let's just hurry things along a little bit. The twin study that you may have come across, Mark and Scott Kelly, this is the one where they had twin astronauts. One of them went up into space for a year, the other one stayed down on Earth, and they measured a whole bunch of differences between them. Being genetically identical, of course, it made it a lot easier to see what changes were happening in space. The official results from that study are out now, so if you want to know what's going on there, go and search up the twin study. I will quickly point out that it's been widely reported that there's been a big genetic change in the one that went up, the Scott that went into space. It's actually not really quite like that. The stories implied that he's become something of a different person because his genes have all changed. It's not actually like that. What else have we got? Oh yeah, the TESS, that's quite an interesting one. The Transiting Exoplanet Survey Satellite. So this is a mission to find planets around other stars. This is very much like the Kepler one that went for a long time and found a whole bunch of new planets orbiting other stars. This TESS has just found its first roughly Earth-sized planet. So that's good news, that's a good start. Well, it's not quite the start, but so we're expecting a lot from this one, and we're actually hoping to find, I don't think I've noted it here anywhere, but it's hoping that this satellite will find perhaps up to 20,000 new planets around orbiting other stars, which is about 5 times as many as we have found so far. So that's really exciting stuff. India is getting ready to launch a probe to the moon. This probe will have a lander as well as an orbiting craft. So Yeah, I'm still going to wish the Indians luck, despite the fact that I'm still absolutely filthy on the Indian government for what they did with blowing up that satellite. So I'm not going to give them any more time than that, other than just to mention it. Beresheet, this is the one that we talked about. We've talked about it a few shows in a row now. It's been on its way to the moon. We've been following it the whole way. You may recall last week it was in lunar orbit. It was just getting ready to land. It was due to land. I think it was actually about a day and a half after the show, and I left that with saying one way or another it was going to be on the moon within 2 days. The only question would be whether it's in one piece or not. Sadly, it wasn't in one piece, so it didn't go very well. This is it coming in to land on the moon. It got a beautiful selfie there as it headed in towards the moon. Unfortunately, its main engine failed, and yeah, it crash landed. So bad luck, guys. This is a private company from Israel that's attempting to put this on the moon. They have said that they're going to try again. So I wish them all the best. It's a great project, that one. They came so close. They really did. It was a really, really good effort, and it was really neat to see all the people getting on board with it. So yeah, good on you. Hope that goes better next time. Look, let's have a quick look at this video here. I think we've got time for that. We've talked a little bit, not that much, but about robots in space. So robots in space can do, well, it's not that they can do things that people can't, it's just that they can go places where people can't more easily, I guess. So there's a lot of advantages of having robots up in space doing work for people. So this is a new company that's based in Japan, I believe, but they've got offices in the States as well. So they're developing a new line of robots that are operated from the ground but can work up in space. So this is just a whole lot of testing they're doing in simulated environments like the International Space Station. So the environment they've got there is simulating modules inside the space station. So that's looking really promising. Yeah, they're actually doing some pretty cool stuff. They did a bunch of tests and like trying to do things that humans would be doing in space, and they were able to successfully pull off about 80% of the human tasks that they gave it. So that's really awesome. You can imagine things like going outside the space station, instead of that whole palaver of having to get your spacesuit on, which takes hours, and the danger and the cost and everything of going outside. If a lot of that work could be done by robots with someone sitting back doing the work on VR, that would obviously make everything much cheaper, much easier, and much safer. And wouldn't it be awesome to have that job? Yeah, instead of just sitting down there playing Minecraft or whatever, you're actually operating a real robot in space. Wow, that would be something. Anyway, that's enough of that. Oh, look at this one here. Oh, I'm not going to should I even talk about this one? I better do. No, I'm not going to. Yeah, I don't like this one. Look at this. Pepsi plans to project a giant ad in the night sky using CubeSats. Oh my goodness. Well, you've heard me talk about this kind of stuff in the past, and you know how much I hate this. Well, I don't even know what to say about this one. It just, I get so upset about this, and like I can promise Pepsi, you will have the mother of all fights from the astronomical community if you go ahead with this one. I just think it's so obnoxious, so arrogant, and it just, no, I'm not even going to talk about any more of that because I'm just going to get myself all worked up. And I've already done a rant for tonight, so we'll just leave that there. So we'll finish off with this part with a little bit of fake news. As always, it's not really so much fake, but misleading headlines. This one's an interesting one. I couldn't really get my head around this one. So I didn't actually end up reading the whole academic paper, but it says a new theory on time indicates present and future exist simultaneously. So that kind of might sound a little bit weird. However, as I understand it, that is essentially what Einstein said 100 years ago. And it seems to me, I read it through the article here, and as far as I can tell, they are describing Einstein's relativity. I'm not really entirely sure what the point of this is. Perhaps if someone else can be bothered reading the whole thing and letting me know, but yeah, I don't get that one. They seem to be describing something that we have thought for 100 years, so I'm not really quite sure what that one's all about. Let's have a look at this one here. The International Space Station is a cesspool of bacteria and fungi, study finds. Well, that's no good, is it? That doesn't sound too flashy at all. So they've been doing the study on the space station where they've been going around and taking samples from all around the space station. It actually turns out to be more difficult than you would think, and they ended up having to bring a whole lot of samples back to Earth, and they have found that there are indeed bacteria and fungi all around the space station. However, it turns out to be pretty much the same as you would expect in any environment on Earth, including your home or even in hospitals. So I think it's fake news to say it's a cesspool of bacteria and fungi. I don't really think that's quite what's happening there. Anyway, I think that will do for all of that. Let me just have a check here. Let's just go and have a look at our comments, shall we? So Rocks Orange says, I think they've canned the Pepsi thing. Pun intended. Nice. I see what you did there. Oh, is that right? That's good news. That would be really, you would have made my day, honestly, if that turns out to be true. So if anyone can back that up with a source or something, that would be really awesome. Now I need to check here. Okay, oh, sorry about that. My apologies. I asked, Carsten, did you have something out there? Did you? Let's go out there. Oh, sorry, was it up here? My apologies. So you did have a question there? What's your question? Do you want to get back to me on that?
No question.
Okay, then, I tell you what, if you do have any questions, just say it, or just comments. You can say anything because, to be honest, the people at home probably don't really want to be listening to me just talking for a whole hour by myself, and part of having the audience here is that I can try and convince you guys to say a few things. So you can do anything you like. You can even entertain us with a little dance if you want to. It's all part of the fun here. So how's our time going? We need to be up to talking about the night sky, don't we? What's happening in the night sky. So let's just have a little quick look at Stellarium, our planetarium software, to see what is in the sky. And I think I've got this on the, right now. So if we go outside right now and have a look at the sky, what have we got out there? So you can see that the moon, we always talk about what the moon's doing, because if you want to be looking at most of the stuff in the sky, it really depends a lot on what the moon's doing. So you can see the moon is starting to get near its full phase now, and so at this time of night that really kind of does kill everything. It makes everything out there very hard to see, and unfortunately, I talked about before the M87 galaxy. So the photo of that black hole is from a galaxy called M87, which we can actually see kind of from New Zealand at this time of year. In fact, it's just to the north there. So if we look at our view here, what we can do is we can show you the names and outlines of the constellations. That makes it a little clearer. So what you want to do is, well, first of all, you're not going to see this with the moon. Don't bother trying this tonight. You need really another few nights, get the moon out of the way. So you won't right now actually see just about any stars really around the moon there. So anyway, where galaxy M87 is between the constellations of Leo and Virgo. So what we can do is we actually just do a quick search. So we'll go for M87 and search for that, and that shows you exactly where it is. So if you look at these two constellations, if you're familiar with the zodiac constellations, we've got Virgo over there, Leo over here, and so it's sort of halfway between these two stars, which is kind of convenient. So if we zoom in on it, you can see as you zoom in a long way, there's actually a whole bunch of galaxies around here. So it's quite a neat little area of the sky. And M87, the one with the black hole in it, is right there. Now, it's very unlikely that you'll be able to see this with the naked eye. You will really need binoculars or a telescope, ideally, to see it. So sorry about that. That's generally the case with other galaxies. Most of what you see there in the night sky is just in our immediate neighbour within our galaxy, the Milky Way. What we're looking at here is something that is in another galaxy entirely. So everything else well, not everything, because there's some other galaxies there, but most of these stars that you can see here, in cosmic terms, are practically on our back doorstep. M87 was it 55 million light years away, I think? Someone correct me if I've got that wrong, but I'm pretty sure you should say here, shouldn't it? Anyway, it's a long, long way away there, but that is where it is. If you want to try and have a look at that with your binoculars or a telescope, that is the area of the sky that you need to be looking in. Right, we haven't got time to talk about much else, so what I'll probably do is let's just go forward. If we go over here and we'll go forward in time a little bit. So there's not much in the way of planets to be looking at just yet. However, if we go forward a couple of hours and you look out towards the east, Jupiter is starting to come into our evening sky. So that's just about, well, it's coming up towards 10 o'clock tonight. I think from about 9:30, you should be able to see Jupiter over in the east. Now, when the moon is out like that, It makes it hard to see all the sort of average and faint stars, but planets are still relatively easy to see. So you should be able to see bright Jupiter over there in the east. Still a little bit late at the moment if you want to be in bed by then, but it's getting earlier and earlier as we go on. Now if we just go forward from there, by, well, let's say by about midnight, Saturn is coming up over there as well. So those two are going to be close to, relatively close to each other in the sky, so they'll be quite nice. And then if you into either staying up very late or getting up very early, we are seeing Venus and Mercury over there in the evening sky. And that's really awesome. 53 million light years away, M87. Thank you very much. So yeah, in the early morning sky, Venus and Mercury together will make a nice sight over there. I think that's pretty cool. So that's probably all we want to talk about for in the night sky. So we also need to get back and have a look at our competition. Now our competition question tonight, thanks to John from last week who suggested we ask you, what is my favourite space mission? So Space Dave's favourite mission ever. Have a guess. You can just type it into the live chat. Or you can email it through to us, you can text, the details are down there. So you've probably got about 5 minutes, so get your entries in now. I forgot to tell you what you were going to win, didn't I? Tonight we are giving away this book, Chris Hadfield, An Astronaut's Guide to Life on Earth. I was a bit nervous about giving this one away because it's worth a lot of money, this book. We sell them for $40 here in the shop, and but it's a great book. This is one of the really good books by an astronaut. I love it to bits. If you're wondering what it's about, Chris Hadfield, he's a really famous Canadian astronaut that he did that David Bowie song on the International Space Station, and he's made all those really awesome videos from the space station, wringing out water in a face cloth. He sings up there. He does really, really cool stuff. He's a great communicator. So his book is sort of a little bit autobiographical. Sorry, you know what I meant by that. He talks about his life, he talks about being an astronaut, but he also talks about using the principles and skills that he's learnt as an astronaut and that they use at NASA, using them as life skills back down here on Earth. So it's a kind of like a self-help book in disguise, really, and it's a great book. I highly recommend it. So we're giving away one of them tonight, suitable for most ages, and I think it's really worth winning. So we've got a few more entries in here. Marie, the Apollo-Soyuz test project. Ooh, actually, I'll tell you now, it's not the right answer, but I tell you what, it's close. That's a good one. So if you don't know the Apollo-Soyuz test project, that was one that was in the 1970s. It was the first time that Americans and Russians actually cooperated and they docked together their different spacecraft in space. And it was pretty much the end of the the space part of the Cold War, the space race, where it was just all a big competition, and it actually really turned things around and showed that actually they can work together, and it was really the start of a whole new era. So great suggestion, that one. Okay then, awesome. Favourite space mission, maybe the Apollo moon landings. It's mine anyway. And Phil's saying Rosetta landing on the comet. These are good answers, actually. Thanks, John, for suggesting this one, because we're getting some really nice answers here. So we will announce, we've just got a few more minutes to go, so you've still got a few more minutes to get your entries in. Now, what else do we need to talk about tonight? Look, we've still got a few minutes before we do the competition wrap-up, and I did say that we would quickly cover everything as fake. This is a segment where we talk about conspiracy theories and things like that. It's always a little bit of a hoot. I will tell you that we're probably not going to spend a lot of time on the show talking about those things. I'm actually thinking that we'll probably make separate videos and maybe just mention them in this part here. So we'll just do a short thing here, but I'm going to play you this video here. So let's just see if we can get this one rolling.
A California man is getting ready to launch himself into the air in a homemade rocket to prove that the Earth is flat.
What do I do if shit goes south? Did you leave a letter or something? What do you want me to do?
My team and myself is going to accomplish the greatest thing in the history of mankind. It's going to change the world. I believe in the geocentric flat Earth model. I'm not going to take anyone else's word for it. I'm going to build my own rocket right here, and I'm going to see with my own eyes what shape this world we live on.
Why should the general public trust you if they can't trust NASA or the government?
NASA receives over $50 million a day. Now, who's going to turn that water faucet off?
A lot of people have got the idea that he's just some kind of a nut. He might just be crazy.
This is what's wrong with the world today. No one knows what's real.
Belief dictates behavior, right? People may be walking around in a false reality.
Let's go! Let's go!
You know, these things are not easy to do.
It's a bomb. It can spring a leak and it'll explode so fast, it'll tear you apart.
To do something like this, it takes everything, and it will take everything from you. Me saying I'm a self-taught rocket scientist is kind of a misnomer because I really don't believe in science.
He believes in science because I know he has force divided by mass equals acceleration. Whether he walks away from this, it's going to be based on science.
Let's go, Mike! Oh, Mike, hang in there, buddy.
Sorry, did my audio thing again, but you didn't have to tell me this time, I caught it. So you may remember that guy, he actually launched himself into the atmosphere. Well, actually, or did he? I can't remember. He was planning to do it, but he actually got shut down and he put it off a bit. But anyway, he's planning to head off up into the sky and show that the Earth is flat. Look, there's no chance that that's going to change anyone's mind, I don't think. He did crash land, did he, Carsten? But he did survive it. Obviously, he did survive. So he launched and then he crash landed, did he? I wonder how high he got. I don't suppose you know how high he got, did he? Do you?
No, just a few hundred meters.
Okay, yeah, because one of the things that strikes me with this is that there's really no chance that he's going to get anywhere near high enough to actually prove anything, surely. So, I mean, I don't know, but I mean, look at the Falcon Heavy that we saw launching just before, or any big rocket that actually gets into space, and then you look at that dinky wee little thing that he's got, and I just can't see it really doing anything. So anyway, I kind of wish him all the best. I've actually got quite a soft spot for guys that do things like that. I think it's quite hard case. Actually, I'll tell you what, Jess, could you please go and grab me the story that's on, there's a newspaper story over there about it's probably towards this end, about the guy that crash landed. It was a story from way back about 1913, I think it was. Is that? Yeah, that's the one. Bring it over here. So this is just in the Space Centre, we've got this thing here. We've got a whole bunch of historical newspapers, and this one here, this is from 1913, and this is a guy who was basically doing the same thing. It wasn't a flat earth thing, but he just got on top of a great big skyrocket and just launched himself supposedly up into the air, but ended up scooting along the ground for about 1 kilometre and really seriously damaging himself. So anyway, people will do just about anything for their 15 minutes, won't they? I think it's awesome. Yeah, good on you. Give it a blast. We'll see what happens. So I think we had one more entry for our competition from Margaret, who was talking about the Voyager ones. Thank you for that, Margaret. And let's just check our comments again to see if we got anything else here. Shuttle Mir program, Marie. And did you have another one? Oh, you suggested the Apollo Soyuz one. The Rox Orange said the Apollo moon landings. You're right, Caitlin. That's dead right. They'll do anything. Right, David Barber, you're exactly right. Yeah, if NASA took the flat earthers up into space, they'd claim they were drugged and had their memories altered. That's exactly right. So I just don't think there's anything you can do to convince them of the truth, really. So, sent Mad Mike. It did actually send him high into the sky. So thanks for that. Righto, so I think we are about ready to do our draw. Are we happy to do the draw for the book? So we'll just go out to our audience here, and Floyd has got all the entries into the space helmet at the back there. Before we do that, I've just been saying that the suggestion for this competition came from John. Well, I talked to John out there in internet land. Turns out John is one of our audience here. Put up your hand, John. So thank you very much for that. We really appreciate that, and I'm glad that you came along tonight to see this competition. So I'll tell you what, do you want to do the draw? Floyd, you come over, we'll get John to pull a name out of the hat, and if you do happen to pull your own name out, we will believe you, don't worry. So here we go. And what name have we got there?
Rox Orange.
Rox Orange, okay then. Thank you, Rox. You have won the book by Chris Hadfield. So if you could get hold of us somehow, probably not in the live chat, but if you could maybe look, any of the details here, you can email us, you can text us, live chat, chat through Facebook, or just get hold of us somehow and give us your address, and we will send that book through to you. So thank you so much for that. Right, I think we are pretty much at the end of the show. Oh, look, tell you what, we've got 2 minutes to go, and we'll be dead on time. That'll be a first, won't it? Normally we go miles over time. So I don't think there was anything else in the news that I really, I don't think there's anything that we missed out on there that we wanted to talk about. Oh, thank you. I do that every time, don't I? I forget to tell you what the answer was. So that should take us right through till the end. So we had all of those awesome suggestions. So what we normally do is we just put everyone in a drawer. That sort of makes it just a little bit fairer, and it means that people who come in later can still have a fair go at it. So the answer, it might seem a little bit lame and predictable to you, and I did think a lot about this one, but my favorite space mission is indeed the Apollo missions, specifically Apollo 11. Now, I know that's an easy one to pick, who picked Apollo 11? Or Apollo missions. So there you go. As I say, I know it's a little bit predictable, but how do you go past that? Honestly, there were some really good suggestions here. I've got to be honest. In fact, if I had to list my top 10, I would say they were probably just about all covered in these questions. So that was really nice to see that, actually. But just everything about the Apollo 11 mission, just the whole, right from the very outset, that whole attitude that we're just going to do it, the willingness to take risks, the fact that the astronauts were really involved in building the machinery and the vehicles to get themselves there. They weren't just passengers or pilots or anything. They actually helped build the whole project. Neil coming into land, I mean, what a legend. That whole story of how he came in, how he had to overshoot their proper landing spot, the alarms going off, everything about it. And you listen to the guy and you would think he was just out for a Sunday drive. It was just all, yep, I'm doing this and now I'm doing that. Yes, I might die any old second, but it's cool. I know what I'm doing. We're all good. So it was just an amazing mission and very, very hard to top that. I have one of the Apollo rockets in the background. I do too. Where is it? Sort of over there. Thank you, Caitlin. That is there, one of the Saturn V's. And in fact, I don't know if you can. You probably can't see it here actually. But if I show you out here, you can actually see it over where Floyd is. Floyd, could you just please point over to the wall of there? There's a couple of Apollo ones over there, and where you can't see it over on the other side. Thanks, Floyd. We've got a really, really big one. In fact, Phil, who is in the comments tonight, his dad actually made that one, and they've got it. They've lent it to us on a long-term loan. So thanks, Phil. We just love that that whole model thing to pieces. It's just really, really awesome. So anyway, that takes us through till 8 o'clock. That's about time to finish up. So thank you so much for everyone for joining in tonight. Please help us out and help spread the word, because word of mouth, I think, is the only way we're going to get this taking off more. So go out there, tell everyone about it. But thanks, Floyd. Thanks, Jess. Thanks for our live audience here tonight. Great to have you guys along tonight. And we hope to see you again here next week. So I think with that, that is good night from us.